Hi, I'm Skye Marthaler. Welcome to Rooftops of the Solar System. Today, our grand tour takes us towards the center and the blinding glare of our sun. But before we start this adventure, take a moment to click that red subscribe button below and the bell icon next to it for all the latest Rooftops of America and Rooftops of the Solar System updates. Today, we visit the world of the winged messenger as we boldly go where no high pointer has gone before.
I had rather be Mercury, the smallest among 7, revolving around the Sun, than the first among 5, revolving around Saturn.
Welcome to Mercury, the smallest major planet in our solar system and closest to the Sun. Speedy Mercury orbits our star at slightly less than every 88 days. It is a world of impact craters, cliffs, and smooth plains. In some ways similar to our moon, and in others vastly different. Mercury. It's the most elusive of all the visible planets. And despite being so close, it's remained an enigmatic little world throughout most of its observable history. And it's only recently that we've begun to unlock its secrets. So, if we're talking about Mercury, you may be wondering what we're doing here in this boulder field in Pennsylvania. Well, perhaps not surprisingly, given its otherworldly appearance. But this place actually shares more similarities with Mercury than you may expect. From Earth, Mercury is a small, shiny planet sitting low in the horizon. Assyrian astronomers made the first recorded observations of it in the 14th century BC, inscribing their findings on stone tablets. They named it Udu Item, which roughly translates to the jumping planet. For centuries, it was thought to be two distinct objects, one for the evening and one for the morning. It wasn't around till 350 BC that the Greeks deduced it was only one. As one of the 7 brightest objects in the nighttime sky, Mercury had significance for ancient astronomers. Due to its speed, the Romans named it after Mercury, the messenger of the gods. Studying Mercury has always been a real challenge from here on Earth. Due to the way it sits low on our horizon, means that our own atmosphere interferes with any observation. And then you have the fact that its rapid revolution around the sun means it's only visible a few days out of every year, either in the morning or in the evening. Then, of course, there's the very real risk that, due to its location near the sun, that observing Mercury through a telescope can actually be quite detrimental to your own eyesight and health. Despite this, intrepid souls took the risk. Galileo observed the planet with a telescope in 1610. But one of the first to unlock a Mercury mystery was the Italian astronomer and Jesuit priest Giovanni Zuppi, who, in 1639, discovered that, like the Moon and Venus, Mercury had orbital phases, which proved it revolved around the Sun. The innermost planet continues to hold its secrets fairly tightly, and unlocking them requires you to think outside the box. Take something as basic as its own rotational speed. It took scientists until 1965 to determine that, and they did it by bouncing radar waves off the planet. The first challenge of highpointing on Mercury will actually be getting there. It's not an easy place to visit, despite the fact that due to its rapid orbit, it is on average the closest planet to Earth. In addition to the intense solar radiation, its location near the Sun means any spacecraft approaching Mercury is subject to massive acceleration from the incredible gravitational pull of our own star. The pathway to Mercury is a long and winding one. Take, for example, Messenger. When Messenger launched from Earth, it flew around the Sun and then back to Earth, and then around the Sun and visited Venus a few times, and then back around the Sun, a total of 15 times, before it was finally able to enter a stable orbit around Mercury itself. This was a journey of 6.5 years, almost 7 years actually, and a distance of 5 billion miles. That's further than the Sun to Pluto. It's not an overstatement to say that of all the significant space exploration achievements that have been accomplished, getting a space probe into Mercury orbit is one of the greatest. It's one of the main reasons that we've only visited this planet twice. The first being Mariner 10 in 1975. It was Mariner that gave us our first real up-close look of Mercury, providing us with a view of the planet that we could never hope to achieve here on Earth. Mariner revealed a world racked by collisions and checkered with craters, but it also unveiled several mysteries as well. Unfortunately, the Mariner mission was only able to photograph about 40% of the planet. Its highly elliptical flight path to protect it from the Sun only allowed it to spot the same section of planet each time it closed in. It'd be over 30 years before we got another chance to see what Mercury had to offer, when, in 2011, Messenger arrived. Unlike Mariner, though, Messenger was purposely designed so it could go into a regular orbit around the planet for a sustained period of time. Over the next 4 years, the Messenger mission would provide a wealth of information about the entire planet, and from a surveying perspective, we now know a decent amount about Mercury. Messenger mapped almost the entirety of the world before it completed its mission. Armed with that knowledge, we can now focus on the areas we want to explore. Mercury is an oddball little world, the smallest of all the major planets, only a bit larger than our moon. But despite that size, it is incredibly dense, the second most dense after Earth itself. And that's pretty much all to do with its massive iron core, which makes up a whopping 85% of its size. The core itself is unique in our solar system, a triple-layer metallic iron heart. One way to think of Mercury is as a huge ball of iron with only a thin layer of dust whipping around our sun. Imagine if you could dig straight down, even at its thinnest part, it would take 1,800 miles of digging before you would reach the outer layer of the Earth's core. Now, compare that to Mercury. You'd be digging substantially less, only 260 miles until you reach the boundary of its outer core. Why Mercury has such a giant core is still a mystery that's being unraveled. There's one theory that this cratered wreck of a world used to be substantially larger, but either a major collision or multiple collisions blasted parts of it away. There's even a line of thought that early in its life, Mercury got hit by Earth itself in a cosmic hit and run. This terrain here was created during our last ice age, when gigantic glacial sheets covered a pretty good chunk of North America. Surprisingly, though, this place isn't a direct glacial remnant. Instead, it came about due to its proximity to the glacier. In ways, it's sort of similar to landforms we find on Mercury, where the direct impact of the asteroid and the comet then scattered debris across the landscape. They also created conditions for other features to then emerge.
Collisions and impacts have been one of the primary defining factors in Mercury's appearance and its geology. Sitting right next to the Sun isn't an ideal place to be. Impacts on Mercury tend to happen at higher speed than they would elsewhere, and the Sun's gravitational influence draws in many unwelcome visitors.
One of the common themes that you're going to find throughout this series is that a majority of the places we're going to visit have been influenced or shaped through impacts and collisions. Mercury, though? Mercury is an entirely different category altogether. It is the most heavily cratered planet in our entire solar system. Now, most of these craters date back to a time period called the Late Heavy Bombardment. This came about when Jupiter and Saturn achieved their current positions in our solar system, and they locked into an orbital resonance and created an intense gravitational pull. Now, we'll talk more about the Late Heavy Bombardment down the road, but there's one point to consider right now, that this time period, the Late Heavy Bombardment, had immense ramifications and consequences, and it's perhaps one of the most significant events in our solar system's history.
For Mercury, with its front row seat, it meant it was now in a direct path as objects from the outer parts of the solar system made their way to the center. The planet would bear the brunt of the beating. Surprisingly, though, Mercury survived, but not unscathed, as any image will show you the planet's battle scars.
Visiting a world of craters means that some of the destinations we're going to be interested in exploring or climbing are going to be directly related to them. And it's time that we start exploring these features in earnest. Exploring Mercury is about choosing one extreme or the other. You'll get to pick from burning heat up to 800 degrees Fahrenheit during the daytime, or the chill of the night when it drops down to 290 degrees below zero. This temperature variance is over 1,000 degrees, making Mercury the planet with the greatest variance in surface temp in our solar system.
While you may assume that extreme temperature variation means Mercury has no atmosphere, that wouldn't quite be correct. It actually does, a very thin exosphere created by the solar wind and micrometeoroid impacts. It's made of evaporated elements from the surface, a combination of oxygen, sodium, helium, potassium, and hydrogen, among other elements. It's a constantly changing environment that has helped identify the makeup of the planet below. Like the moon, you'll want to time your arrival with the Mercurian dawn. Don't feel like you'll be rushed though. due to Mercury's slow rotation. Mornings here last almost an entire Earth month. And that said, you will get a chance to take in one of the unique solar features of this place, Mercury's double sunrise. The combination of the planet's slow rotation and rapid revolution makes it appear as if the sun rises twice before it slowly makes its way across the sky.
As you may expect, there will be challenges to take into consideration in addition to the burning heat and the chilling cold. Perhaps the most obvious is the sun. It's going to appear a whole lot larger and a whole lot brighter in the daytime sky, which means there is going to be a massive increase in radiation.
In addition to arriving in the morning, you're going to want to time your arrival in the Mercury year as well, when the planet is reaching aphelion in its revolution. Due to its very elliptical orbit, this will be the time when Mercury is furthest from the sun and the star appears the smallest in the sky.
It's not all bad news. The good news is, you're going to weigh 38% of what you do on Earth. So, climbing these mountains is going to be a whole lot easier.
Our first destination will be, as expected, a crater. But not just any crater. This is the Rachmaninoff crater, a fascinating structure in its own right, being both relatively new and a peak ring type of complex crater. It's named after Sergei Rachmaninoff, the great Russian composer, whose music you are currently listening to. It is home to the lowest point on the planet. Getting to the low point will require some skill as you navigate through the double rings to the bottom of the main crater. Once there, you will actually head to another, newer crater, and then proceed to the bottom of it. At the floor is the Mercury Low Point, at a depth of approximately 17,650 feet below the global average.
When you reach the bottom of these craters, you'll notice it's awfully cold and dark. Well, these are clues to another one of Mercury's mysteries. The mystery of its ice. Yes, you heard that correctly. Mercury has ice. And not just a little bit either, but several billion gallons, they think. All tucked away in the dark depths of these craters, where the sun's rays never shine.
If that's the case, then Mercury, despite being burned to a crisp by its next-door neighbor, could be one of the wettest places yet discovered in our solar system. So, how is that possible? Well, it all has to do with Mercury's axial tilt, or lack thereof. Another bit of Mercury weirdness. Mercury basically stands straight up and down, the closest planet to zero tilt in our solar system.
This means on Mercury, there are places that are trapped in eternal darkness. And it's in these inky black depths where they think, is water. And some estimates up to 50 meters thick. So, chalk Mercury up as your next extreme winter sports destination. That said, while that axial tilt can lead to eternal darkness, it may very well create another phenomenon that may be of more interest to highpointers.
This tiny world may be home to one of the unique features found in our solar system, a peak of eternal light, or at least as close as we may get to on a planet. A peak of eternal light is exactly what it sounds like, a mountaintop or high point bathed in the constant glow of the sun. It is another similarity the planet has with our moon. That also has a few locations that could be candidates.
Mercury would be a prime candidate for this phenomenon for several reasons that we've already mentioned. Its close proximity to the sun and how large it appears in the sky, and then, of course, the lack of axial tilt. And finally, it has 0 moons, so there's no chance of even an eclipse casting any shadow.
At the poles of Mercury, the sun sits low in the horizon every day, and those are the 2 places on the planet where this phenomena may occur. At the present, the North Pole does not appear to have one, though more data may be needed before true determination can be made. So that means we need to head to the South Pole, near the Xiao crater.
The crater is named after the famous 13th century Chinese artist and calligrapher Xiao. And like most things on Mercury, it has a story to tell. In this case, 40% of the crater being in permanent shadow, and it's theorized to hold significant quantities of ice. It also takes center stage in a 1997 short story about climbers on Mercury called Crossing the Xiao Crater.
For us, though, the crater is a bit of a sideshow. We'll be more interested in the location near it, to be specific, at coordinates 89 degrees south, 50.7 degrees east. It's here where we will find the closest thing Mercury has to a peak of eternal light, illuminated over 80% of the time.
We've got one more stop related to Mercury and its craters, its tallest mountain. And to get to it, we need to head back north, to a landmark that quite literally can't be missed. The Caloris Basin is the largest surface feature found on the planet. It's the result of one of the largest, if not the largest, impacts that Mercury has ever endured. The end result was a basin 960 miles wide. It was first discovered by Mariner 10, but due to that probe's flight trajectory, it was only able to image about half of it. The rest remained beyond the horizon. It wasn't until Messenger arrived that we finally were able to see the full extent.
The basin was formed around 3.8 billion years ago when an object, estimated to be about 100 kilometers in width, smashed into the planet. The end result was an impact crater so large that you could fit the entire state of Texas in it. To understand the force and impact of this collision, you don't want to just take in the full scale of the basin, but also the landscape on the opposite side of the planet.
At the antipode of the basin, you'll find something simply called weird terrain. This is an unusual, hilly and broken terrain found nowhere else on the planet. It's theorized that these features came about because of the impact at the Caloris Basin.
The force of that collision was so large and powerful that it sent a seismic shockwave through the planet that literally deformed the other side. If the object that smashed into Mercury had been any larger, it could have potentially cracked the planet in two. Back at the Caloris Basin, you'll notice the ring around the edge. It's there that you will find Mercury's tallest mountain. These groups of massifs were created when the impact occurred and rise over a mile high. Of all of them, we'll be most interested in the group at the southeastern part of the basin.
While you may wish to travel right there, it's worthwhile for a few reasons to actually take a trip across the basin floor. The first is that it gives you a chance to take in another one of Mercury's wonders, the magnificent Apollodorus crater in the Pantheon Fossae.
Even on a world filled with craters, this one stands apart. When it was first viewed up close, it got the nickname the Spider due to its striking, arachnid-like appearance. The crater was named after Apollodorus, the famous Greek architect. The area surrounding the crater has numerous fossae, or trenches, running out from it, and has been named after the Pantheon in Rome, the building Apollodorus is said to have designed, and whose dome has a reminiscent pattern.
There's still the lingering question of whether the crater and the fossae are actually related to each other. Another Mercury mystery yet to be solved. But there is one thing that can't be denied. These trenches make up an absolutely captivating scene on the Mercury floor, and they'd be well worth exploring.
The other reason to journey across the basin is that it will give you one of the best views of the Caloris Montes. From the floor, you will be able to take in the prominence of the massive as it rises up, a mass of uplifted and fractured pre-basin bedrock covered by a layer of ejecta, or the debris that rained down after the collision.
Caloris means heat in Latin. It's where we get our word calorie from. So these are the heat mountains, or the mountains of heat. A pretty fitting name for a group of peaks that would be baking in the Mercury midday sun.
Upon arrival at the foot of these peaks, you're going to be faced with two challenges. The first is the terrain. The surface of these mountains is jagged and rough. The second is a bit of surveying and exploration is going to be necessary, because the highest peak on Mercury has yet to be pinpointed among this group.
Once you reach the summit of this unnamed peak, well, you'll be on the tallest mountain on Mercury. But you're not going to be finished with Mercury just yet, because like the moon, Mercury's tallest mountain is not its highest point. In fact, these peaks here play second fiddle to another landform on Mercury, one whose striking appearance makes the Caloris Montes pale in comparison. The exact formation of this boulder field is still being determined, but there are a couple of usual suspects. The two primary ones are the forces of expansion and contraction. One of the things about the glacial ice sheets is they created an area of permafrost around them. And this led to a constant thawing and freezing of the land, which in turn cleaved these stones from the bedrock. Now combine this with frost heaves, where the ice underground freezes and expands, thereby lifting these boulders and other surface material up to the surface. Now, Mercury probably doesn't have frost heaves, but it does have those severe temperature fluctuations. And the force of contraction still shapes the Mercurian landscape even today.
The other major geological driver on Mercury is its massive metal core, or more importantly, what's happening to it. The fact that over billions of years, it is still slowly cooling.
Most metals, when they lose heat, respond in a similar fashion. They contract and get smaller. This same is true even for something as large as a planet, especially one that's so metal rich. Mercury has shrunk. And because its crust and mantle are so thin, this shrinking has led to some dramatic effects on its surface.
Mariner 10 was our first up-close glimpse of this activity, and Messenger would later provide even more startling details. The clues were in several geological features identified on the surface of the planet. The wrinkles and ridges were evidence of some form of tectonic activity. It's been estimated that Mercury may have shrunk up to 8 miles in diameter.
While it may not seem to be a whole lot of distance, especially on a planetary scale, actually, it's quite significant. One way to think about this is Mercury as a grape, sitting in the sun, slowly turning into a raisin. The wrinkles and ridges starting to form as Mercury quakes ripple across the surface. For high pointers, they'll be interested in the most dramatic of these results. The scarps, giant stair steps that stretch across the landscape.
Mercury Scarps can wind across the landscape for hundreds of miles. They are theorized to have formed as the crust contracted, which in turn built up surface pressure, eventually becoming so great it forced the land to crack and lift to release it. While the large, long ones are fairly straightforward to explain, what is even more curious are the smaller scarps that have been discovered inside craters.
These smaller ones were a clue that led to a fascinating discovery. They appeared geologically younger than the larger ones. This led scientists to believe that Mercury was still shrinking. It was a remarkable conclusion because it threw out the notion that this planet is a dead world. Instead, evidence points to the contrary. Mercury is a geologically dynamic and vibrant planet.
If you have the opportunity, there are several scarps you'll want to investigate as you traverse the Mercury surface. The Discovery Rupees cuts right through the Rameau crater, and along with the Adventure and Resolution Rupees, is part of a geographically close trio of scarps. Or you can visit the Beagle Rupees, one of the most curved of all Mercury's lobate scarps. That, in turn, has lifted half the floor of the Svensdotter crater. Finally, there is the Enterprise Rupes, the largest of all of them, with a length of 621 miles, rising 1.8 miles above the surface. Named after the USS Enterprise, the steamship that first surveyed the Mississippi and Amazon rivers, this scarp cuts right through the rim and basin of the Rembrandt crater and skirts the edge of Mercury's Great Valley, another Mercurian wonder that stretches over 600 miles long, is 250 miles wide, and up to 2 miles deep. Standing on top of the Enterprise Rupes will provide one of the best scenic views on the planet.
Mercury Scarps provide some excellent elevation and some incredible views, but they're still not the highest point on the planet. To find that, we need to journey onward, this time towards the equator, in some of the oldest terrain on Mercury.
The Messenger mission greatly increased our understanding of the planet, and it has taken years to sort through all the information sent back. In 2016, NASA used over 100,000 images and all the elevation data gained to create a topographical map showing the entire Mercury surface. And with this tool, we can now pinpoint Mercury's high point. You'll find it just below the equator in the Mercury highlands. The highest point on the planet measures in at 14,678 feet above the planet's global average elevation, a bit taller than Mount Whitney, California, here on Earth. Since it doesn't really have a designated name yet, we'll call it Point Hermes.
You may find by the time you reach this place that it's a bit anticlimactic, particularly after all the other Mercury adventures that you've had. And the view probably is a little underwhelming. But don't be disappointed. You've now reached the rooftop of Mercury. And you can leave the planet knowing that you've experienced some of the best that the Winged Messenger has to offer.
It's time for us to depart, Speedy Mercury, and continue our adventure. While we may be leaving, Mercury won't be alone for long. The Bepi Colombo mission is scheduled to arrive in 2025. This joint endeavor of the European and Japanese space agencies will continue to unravel and solve some of Mercury's mysteries, and hopefully discover a few more, and provide us with a fuller understanding of the Winged Messenger planet.
I'm Skye Marthaler. Thanks for joining me on this episode of Rooftops of the Solar System. Before you go, click that red subscribe button below. On the next episode, we'll journey to our evil twin, the beautiful but deadly world of Venus. I'll see you soon.